Hello students, this is a question from the chapter force which many students find difficult to solve because this is a question pertaining to the clockwise and anti-clockwise moment. I'm sure most of you will be confused solving these type of questions. Here is a simple explanation which I can provide you. In the given figure, a body is acted upon by several forces, namely A, B, C, D and E. We need to calculate the total or the resultant torque due to the forces at the point O. Okay, so here first of all we need to know the formula. The formula for calculating the torque is equal to force multiplied by the perpendicular distance. Okay, this is the formula for torque, and we need to consider the clockwise and anti-clockwise moment before solving this problem. Okay, so let me show you the clockwise and anti-clockwise moment. Here's let us look at the force A. The force A tend to rotate this body in this direction. Okay, the force A, which is acting at the point here, tend to rotate the body in this direction. This is a counterclockwise direction or the anti-clockwise direction. Also, you can observe that the force acting at the point A tend to rotate this in the anti-clockwise direction. Also, you can observe that the force C, which is 80 Newton, the force acting at the point C also rotate this in the counterclockwise direction. Okay, so these two forces, which are 20 Newton and 80 Newton, tend to produce the anti-clockwise moment. One thing you need to keep in mind is that the anti-clockwise moment is always taken as positive. Okay, so here the force 20 Newton and 80 Newton produces anti-clockwise moment, which is taken as positive. One thing we need to understand here is that the perpendicular distance is given in the proper SI unit, so we don't have to make any further conversions. So the resultant anti-clockwise moment will be 20 Newton multiplied by the perpendicular distance, which is 1 meter, plus the 80 Newton multiplied by the perpendicular distance is 3 meter. So you will get 20 plus 240, which will be 260 Newton meter anti-clockwise. Okay, so anti-clockwise, since anti-clockwise is taken as positive, you can put a positive sign in front of it, which is indicative that the resultant moment is anti-clockwise. Okay, now let's look at the clockwise moment. The forces 30 Newton and 50 Newton tend to rotate the body in a clockwise direction. This 30 Newton, when applied at the point here, tend to rotate the body in clockwise direction. Also, the 50 Newton force when applied at the point E tend to produce a clockwise direction. Another thing is that the clockwise moment is always taken as negative. Okay, so we can calculate the clockwise moment, which is 30 multiplied by the perpendicular distance 4 plus 5 multiplied by the perpendicular distance 50 multiplied with the perpendicular distance 5, which will be 120 plus 250, that is 370 Newton meter in the clockwise directions. Since it is the clockwise moment is taken as negative, you can put a negative sign. Okay, so here the resultant force due to the clockwise moment is minus 370 and anti-clockwise is plus 260. What will be the moment produced by the force D? The D, since the force D is in line with the point A, there is no perpendicular distance. So this force D, which is 200 Newton, does not produce any torque because there you can't find any perpendicular distance. That force D is in line with the point O. The force D lies at the same line in the point O, so it does not produce any torque. So the resultant will be, we have the clockwise moment is equal to minus 370 Newton and the anti-clockwise moment is equal to plus 260 Newton meter. So the resultant will be the difference of the two, which is minus 370 plus 260, which will be minus 110 Newton meter. The negative sign indicates that the resultant moment is also clockwise. Okay, the clockwise moment is given by negative sign. So if we find the resultant of this two, minus 370 plus 260 will give us a result of minus 110. Okay, so the net result